Good morning, students. Our today's topic in the topic of complex number is argument of a complex number. So this is the first topic which we are going to read today. Today, a lot of topics are left. So concentrate yourself. For argument of a complex number, some concepts first you have to understand and learn. The argument z is equal theta is equal to argument z of a complex number. Z is equal to x plus iota y can be calculated based on the position of xy, where x is the real part of the complex number and y is the imaginary part of the complex number. So concentrate yourself. If x and y both are positive, it means, look here, these are x's, here x axis, and here y axis. So y is positive here, x is positive here, x is negative here, y is positive here, and y is negative here. These are the very basic concepts which you have learned in your junior classes. So if x is greater than y and y is greater than y, so it means first quadrant will be there. So quadrant will be first, sign of the theta will be positive, and theta, that is argument, is tan inverse y by x. So this will be the formula. But if x is lesser than 0, it means it will be here, and y is greater than 0. So it means now we will be in second quadrant. So here is second quadrant. Sign of the theta will be positive, so it means argument will be positive, and the theta will be equal to tan inverse y by x plus pi. If x is lesser than 0 and y is lesser than 0, so it means third quadrant will be there. Sign of the theta will be negative and theta will be equal to tan inverse y by x minus pi. If x is greater than 0 and y is lesser than 0, so it means x is greater than 0 and y is lesser than 0, so fourth quadrant will be there. Sign of the theta will be negative and theta will be equal to tan inverse y by x. So these are some general concepts for the argument. Okay, usually argument of z is greater than 0 if y is greater than 0, and argument of z is lesser than 0 if y is lesser than 0. And here are some questions that will make your concepts more clear. The question is, find the argument of 1 plus 2 iota. Here xy will be 1 and 2. From here you can see x is greater than 0 and y is greater than 0. So it means first quadrant will be there. Okay. And theta will be positive. And theta is tan inverse y by x. So that means tan inverse y is 2, x is 1. So 2 over 1. Okay, very final step will be, first change your calculator into radian mode and find tan inverse 2. That will be equal to 1.107. So this is the argument of this complex number. Likewise, if you come here, xy will be minus 1 and 3. From here you can see x is lesser than 0 and y is greater than 0. So x is lesser than 0 and y is greater than 0. It means second quadrant. So in second quadrant, theta is positive and tan inverse y by x plus pi is the formula. So theta is positive and theta is equal to tan inverse y by x plus pi. So now we will put the values into this one. So tan inverse y is 3 and x is -1 plus pi. So solve it on the calculator now. So shift tan, small bracket start, -3 by 1 bracket close plus pi. Shift tan, small bracket start, 3 by 1 bracket close plus pi. So the answer is 1.893. Here is the third part. In third part, you can see x, y is equal to -4, -1. So x is lesser than 1, lesser than 0, and y is lesser than 0. So it will be third quadrant and theta will be negative. In first and second quadrant, theta is positive, and in third and fourth quadrant, theta will be negative. So now theta is equal to tan inverse y by x minus pi. So putting values into this one, tan inverse y is -4, x is -1 minus pi. So solve it on the calculator. Shift tan, bracket start, 4 divided by 1 minus pi. Answer is -1.816. Minus sign is there because theta will be negative. Here is another part. X, y. X is 5, y is -2. So x is greater than 0 and y is lesser than 0. It will be fourth quadrant. So that's why theta is negative. And theta will be equal to tan inverse y by x. So tan inverse y is -2, x is 5. So solving it on the calculator, shift tan, small bracket start, -2 by 5 bracket close. Answer is -0.381. So this is the method for finding the argument of a complex number. The next thing that we are going to read in the complex number is polar form and exponential form. Polar form is r cos theta plus iota sine theta, whereas the exponential form is r e iota theta, where r is z mod, and the formula for finding this z mod is x square plus y square square root. So these are the concepts which will be used now for solving the questions of polar form and exponential form. So concentrate yourself now. Here is a question: -1 minus square root 3 iota, and the requirement is find the polar form and exponential form. So you have to be very careful now. So first, actually we are going to find the missing values. So theta, that is argument, and R, that is Z mod, are the requirement. First we will find these two values and then we will put into the formulas to get the polar form and exponential form. So look now, R is equal to Z mod, which is equal to x square plus y square. Okay, from here you can see x is -1 and y is minus square root 3. So these are the values which are going to be put into the formula. So x square plus y square whole square root. This is the formula for finding the z mod. So we are going to put the values into this one. So -1 square plus minus square root 3 square whole square root. So from here 1 plus 3 square root, that will make 4. So 2 is the value of the R. Now if you can see x is lesser than 0, so finding the argument, first we have to check which quadrant will it lie. So x is lesser than 0 and y is lesser than 0. So here is the quadrant, x-axis and y-axis. So x is negative and y is negative. So this is the quadrant. So it means theta is negative, first thing. And second thing, theta will be equal to tan inverse y by x minus pi. So putting values into this one. So tan inverse y is minus square root 3 over x is -1. Minus pi is still there. So solving it on the calculator. So shift tan square root 3 minus pi. So answer is minus 2.094. From here now you are able to find the polar form and exponential form. So polar form. The complex number is -1 minus square root 3 iota. That is equal to r cos theta plus iota r sin theta. So here from you can put the values and solve it. So r is 2 cos theta is minus 2.094 plus iota, r is 2 sine and theta is minus 2.094. Okay, cos always absorb the negative sign, so it will be 2 cos 2.094, but sine is not able to absorb the negative sign, so it will push negative sign backward. So minus iota 2 sine 2.094, and this 2 can be placed here. So minus 2 iota. So this is the polar form of the this complex number. Here is also r. Okay, now exponential form. The exponential form of a complex number is -1 minus square root 3 iota is R E iota theta. So R is 2 e raised to power iota, and theta is minus 2.094. So this is exponential form. The next thing that we are going to read in the complex number is geometrical interpretation and geometrical interpretation of addition. So look here, here is a question. If z1 is equal to 1 plus iota and z2 is equal to 2 plus 3 iota, explain with a diagram the geometrical interpretation of z1 plus z2. So look now, solution. Actually, we have to find first z1 plus z2. So z1 is 1 plus iota and z2 is 2 plus 3 iota. So from here you can see 1 plus 2, 3, and 1 plus 3, 4 iota. So actually in coordinates form this is 3, 4. And okay, if we call it P, Q and R, if we call it R, and P is Z1, that is 1, 1, and Q is Z2, that is 2, 3. So we have a we are representing Z1 with P, that is 1, 1, Z2 with Q, that is 2, 3, and some Z1 plus Z2 with R, that is 3, 4. So look now, this we have to draw on the diagram now. So these are the numbers. The maximum number on the x-axis is 3 that I can see. So 1, 2, 3, 4, 5. And on the y-axis, the maximum number is 4. So look now, 1, 2, 3, 4, 5. So here is the origin, that is 0, 0. So P is 1, 1. So this is P. Okay, Q is 2, 3. Here is 2. And here is 3. So here is Q point. So look now, with the help of scale, you will join this point with the origin. So here is Q point, and the R is 3, 4. And here is 3, and here is 4. So now you have to join this point with these 2 points, P and Q. Here is P. So with the help of scale, you will join these points. So look now, like this. So this is the geometrical representation. Here will be R. So this is the geometrical representation of the addition. Here are some more concepts. So for multiplication, so if two complex numbers are multiplying with each other, and we have to take the mod, that is magnitude, so we will take individually the magnitude of two complex numbers. And if two complex numbers are multiplying with each other, and if we have to take the argument of this one, so we have to take the argument of these two complex numbers and add them. So this is the concept for multiplication. Now division. So if two complex numbers are dividing with each other and their mod is there, so mod will be distributed separately with them. So we have to take the magnitude independently, separately, and then divide them. And if we have to take the argument of two complex numbers that are dividing with each other, so actually we have to take the arguments of these two numbers and subtract the denominator from the numerator's argument. So these are two concepts which will be used in multiplication and division. So here is a question. If OPQ represents the origin, the complex numbers 1 plus square root 3 iota and square root 3 plus iota respectively, find the angle between POQ. So actually angle is the requirement and POQ. Here is a concept. Whenever this kind of the angle is required, so actually you people are required to find argument of uh, first P is actually this complex number. So this will be put in the numerator, 1 plus square root 3 iota, 1 plus square root 3 iota over square root 3 plus iota. So here is the concept. Look again. So whenever P or Q is required, so P first complex number will be written in numerator and second in the denominator. So actually we are required to find the argument of 1 plus square root 3 iota minus argument of square root 3 plus iota. So actually this is required. So now we have to complete the values and then we will put the values into it. So look now, solution. The first complex number is 1 plus square root 3 iota. So xy is 1 square root 3. Both are positive. So first quadrant. So theta positive and theta will be tan inverse y by x. So putting values into it, y is square root 3, x is 1. So tan inverse square root 3 over 1. Okay, tan is square root 3. So square root 3 is actually, here is 30. So use the calculator. Change your calculator into radian mode. So tan inverse square root 3. Bracket close. 1.07. Okay, this is the first argument. Now the second. Second complex number is square root 3 plus iota. So these are again positive. So first quadrant, theta positive, and theta will be equal to tan inverse y by x. So tan inverse y is 1, x is square root 3. So from here, first change your calculator into radian mode. Okay, tan inverse square root 3. 1.047, and from here tan inverse 1 by square root 3. Answer is 0.524. So now putting values into it. So look now, argument of this is 1.047 minus argument of this is 0.524, and answer will be 1.047 minus 0.524, 0.523. So this is the answer. Now we are going to read another new topic in the topic of the complex number, that is equilateral triangle. The concept of the equilateral triangle is this one. If P represents any complex number Z and U is equal to 1 by 2 plus square root 3 over 2 iota, let Q represents the complex number Q is equal to ZU and R the complex number R is equal to Z over U. Then OPQ and OPR are the equilateral triangles. So this is the concept, and vice versa also applies. So if the triangles are equilateral, so this concept will be applied. So here is a question now. So look now. Question is, let P represents the complex number 3 plus iota and Q represents the complex number A plus B iota and O represents the origin. If OPQ is equilateral triangle, find the possible values of A and B. So these values are required. Okay, solution is here. Let Z is equal to 3 plus iota and U is equal to 1 by 2 plus square root 3 by 2 iota. So this is the thing. Then possible values of Q will be ZU and Z over U. So these will be the possible values. So okay, now we are actually going to find this and this thing. So ZU, Z is, here is Z, 3 plus iota, and U is 1 by 2 plus square root 3 by 2 iota. So multiply these values now. So this vector will be multiplied this one. So square root 3 by 2 plus 3 square root 3 by 2 iota plus 1 by 2 iota and plus square root 3 by 2 iota square. Okay, from here iota square is minus 1, so it will be minus, so 3 by 2 and minus square root 3 by 2. These factors are combined and iota can be taken as common from these two factors. So 3 square root 3 by 2 plus 1 by 2 and iota is common. From here 3 minus square root 3 by 2 plus from here 3 square root 3 plus 1 by 2 iota. Okay, this is one possible value. The second possible value will be Z over U. So Z is 3 plus iota and U is 1 by 2 plus square root 3 by 2 iota. Okay, Change the sign of the imaginary factor and multiply and divide by the same value. So 1 by 2 minus square root 3 by 2 iota over 1 by 2 minus square root 3 by 2 iota. Okay, in the numerator, the values will be multiplied like 3 by 2 minus 3 square root 3 over 2 iota. Now this will be multiplied, so plus 1 by 2 iota, and this will become square root 3 over 2 iota square. And in the denominator, we will have 1 by 2 square minus, because a plus b into a minus b whole formula will be applied. So 1 by 2 square minus square root 3 by 2 iota whole square. Okay, from here iota square will be minus 1, so this factor will become positive. So taking LCM at the same time, so 3 plus square root 3 over 2, and from here take iota common, so plus 1 minus 3 square root 3 over 2 iota. So this is other possible value. So this is the answer. Okay, in denominator we have also some values. So that will be 1 by 4, and iota square will be minus 1. So this factor will become positive, and 3 by 4. So this will become 1. So cancel. So in the next step, only numerator will be placed. So this is the other possible value.